We are talking about a concept of density first. So density, we know it is mass upon volume. So mass is measured in kilogram and volume is measured in meter cube. So therefore the unit of density is equal to kg per meter cube, and the CGS unit is gram per centimeter cube. It is a scalar quantity. If you want to convert, say for example, this is 800 kg per meter cube is the density, and you want to convert it into CGS, you will have to divide it by 1000. 0.8 gram per centimeter cube. That will be the CGS value. This will be the SI value. So on the other hand, if you have 1.2 gram per centimeter cube and you want to convert it into SI, so you will multiply by 1000. So that will be 1200 kg per meter cube. So we have seen what is density. We have seen how to convert density from SI to CGS and CGS to SI. The third thing is concept of relative density. It is defined as the ratio of the mass of a certain volume of a substance to the mass of an equal volume of water at 4 degrees Celsius. This is one way of defining it. But the easier way to define relative density is a substance is the density of that substance to the density of water at 4 degrees Celsius. Density of water at 4 degrees Celsius is 10 to the power 3 kg per meter cube, okay, or 1 gram per centimeter cube. So therefore, if you have a density of, say, for example, wood to be 800 kg per meter cube, then if you want to find relative density of wood, what will you have to do? 800 divided by 1000, and that will be 0.8. Okay, and relative density has no unit because it is a ratio. If density of, say, iron is 8000 kg per meter cube, then density of iron in CGS is 8 gram per centimeter cube, and it is 8 as relative density. That is how you remember. Okay, so I'll give you one more example. So let's say density of glass is 2500 kg per meter cube. So that will be 2500 divided by 1000. That will be 2.5 gram per centimeter cube. And therefore 2.5 will be the relative density. So therefore, what will I write? Relative density of glass is 2.5. Relative density of gold is 19.3. So therefore, density of gold will be 19.3 gram per centimeter cube. So that will be 19.3 into 10 to the power 3 kg per meter cube. Okay, so this conversion, you should be able to do it. So in short, if I have to write, so density in terms of kg per meter cube is suppose x, then density in terms of gram per centimeter cube will be x upon 1000. Let's say that is y. So this is x kg per meter cube. This is y gram per centimeter cube. Then relative density is just y. There is no unit for that. So this solid that we are talking about, W1 weight of the solid in air and W2 weight of the solid in water. Relative density of the solid is given by W1 upon W1 minus W2. Okay, so that is weight of the solid in air upon loss in weight of the solid. So this is how you measure relative density. So to do that, what we need to do is, say for example, you have spring balance here and you are measuring its weight. So this is W1 because that is measured in air. Now inside the beaker and this particular solid, we are going to immerse it inside water. Now on immersing in water, this particular substance weighs less, that is W2. Okay. So we record W1. So that will be your step number 1. Okay. So that means take the solid, attach it to the spring balance and see the weight of that solid. So that is W1. W2 is immerse the solid in water and record the weight in water. So that is W2. The step 2. Step 3 is to measure relative density by using this formula W1 upon W1 minus W. So this is a simple step procedure to measure the relative density of solid that sink in water. Relative density is equal to W1 minus W2 upon W1 minus W3. So W1 we all know, weight of the solid in air. Now we have W2, that is weight of the solid in the liquid, whose relative density we have to calculate, and W3 is weight of the solid in water. So step 1, we will measure the weight of the solid in air, record this. So that will be termed as step 1. Step 2 is we'll take a beaker. So that beaker will be containing water, immersing this inside water to record the weight of that body in water. And step 3, we are going to immerse this solid, the liquid, and we will measure the weight of the solid in this liquid as W2. And then step 4 is to measure the relative density of the liquid by substituting the value in this formula, that is W1 minus W2 upon W1 minus W3. This is the block. So the weight of the block acts at a point. Now that point is the meeting point of these diagonals. Now this point is called as center of gravity. Center of gravity. Okay. Now when this body is inside a liquid, let's say it is inside a liquid like this point, like here. So that time there is a point over here. That point is called as center of buoyancy. So this is the block. Find the center of gravity. You draw diagonals like this. So this point is called as the center of gravity. Let's say this portion of the block is inside water or liquid, is you will have to draw diagonals for this block. So this will be the center of buoyancy. Okay. So these will be two different points. Fine. So this is one important thing. And of course, the center of gravity, weight acts downward. So that is called as weight in air. And wherever is the center of buoyancy, that is acting upward. That is the upthrust that we have seen. Okay. So now there is another case. Say for example, this block is completely inside liquid. So first of all, again, we'll draw the diagonals. So the diagonals will give us the center of gravity. So this is the center of gravity. And then if you imagine the block to be completely submerged inside, in this particular case, the same point will be the center of buoyancy. So G and B are the same points. For the diagonals, the center of gravity and center of buoyancy do fall in the same line. They do fall on the same line. Okay. It's only when the whole body is under the liquid, then they coincide. The center of gravity and center of buoyancy will be same. The weight of the body in air, for that we are taking this whole volume, that is V, is equal to volume of the solid times density of the solid into gravity. And when we say the buoyant force, that time we are talking about only the volume when the body is submerged inside, okay, submerged inside the liquid, time density of liquid into gravity. If the body is floating, then weight in air is equal to the buoyant force. And therefore what you have is volume of the body, the whole body, time density of the solid into gravity is equal to volume submerged time density of liquid times gravity. So this will get cancelled. And what we get is the total volume upon the volume submerged will be equal to density of liquid upon density of solid. So there will be quite a few numericals which will be based on this, where the diagonals meet, that will be the center of gravity. So that is given by the letter G, and depending upon what portion of the body is under liquid. So say for example, only this much is under liquid. Okay. So you imagine this to be another rectangle and you draw the diagonals of that rectangle, and where the diagonal intersect, that will be the center of buoyancy. Okay, you will notice that whenever you